Hello, geometry students. Welcome to the 8th and final week of our continuous learning opportunities for the Olathe School District. My name is Mr. Brian. I'm a math teacher at Olathe West High School, and I'll be working through some of the examples for you for this last week of problems. One thing that I will note before we get into this that's going to be a little different from some of the other weeks is every lesson up to this point has been old information that you guys should have seen in class, specifically this year. So whether that was dealing with triangle properties or similarity or quadrilaterals or whatever it was, you should have seen it already. For this final week, we decided we wanted to do a little bit of new information. So the topic for this week is going to be area and volume. And so some of these things you might have seen before: area of a square, area of a triangle, so on and so forth. But there will be some new pieces of information and new equations that we're going to use for some of these problems. Good news is that as long as you understand how to use an equation, as long as you understand how to plug variables into different spots, then you should have no worries or no issues working on some of these problems. So with that being said, let's get into it and let's see if we can finish off this year strong and get you guys to your summer. Okay, so if you're looking at the different Google Docs and pages that we put up for our lesson this week, you should see this one of these first pages with the equations for area and volume. So if you have not already, here's what I would recommend that you do, because all these equations are going to be very important, is I would recommend that you go through and you name each shape and then what the equation is or formula is to find the area or the volume of that shape. Might take a second, and you can pause your video if you need to, but this will help us a lot as you're going through the problems. If you just have this on a separate sheet of paper or on a different screen on your computer, then you'll quickly be able to look at these equations and then be able to use them. Okay, so we should have 6 equations for area and then 3 equations for volume, and we'll kind of talk more about how to use those and what those look like and all these different pieces of the equations as we get to these different examples. But like I said, if you haven't already, take a second, write down the shapes of all the names of all these shapes, and then write down all these equations. I'll give you a sec to pause your video and do that. Okay, so with that being said, once you've got those written down, we can start working on our different example problems. So we'll start here, start easy, and then kind of work our way up. So first one, find the area of the triangle, and then assume the dots are 1 centimeter apart. So here's what I would recommend if you want to make sure that you're getting all of these correct and doing them all the right way, is before you get into any of these problems, I want you to just underline the name of the shape that you're looking at. Okay, it might seem tedious, but it really will help you keep track of which equation you need to use and then how you're going to go about this problem. Okay, so I've underlined, we know we're looking at a triangle. That means I can look back at my equation sheet or scroll up this page, and I see the area of a triangle is the base times the height, and then divided by 2, which is an equation hopefully you guys have seen before. So area equals base times height divided by 2. And this is a B. Sorry that my B's kind of look like 6s. If you're one of my students, then this is not new information. If it is, just making sure that you're paying attention and checking to see that. But this is the base times the height. Okay, so we have this here. So we just need to find the base. So we can just count this, and like it says, they're all 1 centimeter apart. So we just count 1, 2, 3, 4, 5. So a base of 5 centimeters. The height we can count as well, just the distance from the top to the bottom. So you have a distance of 1, 2. So I'll write this out to the side, 2 centimeters. And now once we have our equation, once we have our variables, we just need to plug in and simplify. So the area is going to equal the base, which we said is 5, times the height, which we said is 2, and then all divided by 2. And then just need to simplify. So 5 times 2 is 10, and then divided by 2, and 10 divided by 2 is going to give us 5. Okay, and on all these problems and all the practice problems that you guys are going to be working on your own, we've given you boxes or places to put the answers here. So I'm going to put the area equals 5. And then once you find the number, you always need to do 2 things. Number 1, you need to look at the unit that we're dealing with. So in this case, it's centimeters. And then the second thing is you need to ask, is it square, is it cubed, so on and so forth. So anytime you're dealing with a problem with area, the answer is always going to be whatever your unit is squared. So in this case, area is going to equal 5 centimeters and then squared. And that's my final answer. I need to make sure to include that unit in all these problems. Okay, so with that in mind, let's get to example 2. All right, so I'm looking at this here, and we want to find the area of the parallelogram. So again, what I'm going to do before I get started is I'm going to underline the shape that I'm looking at, parallelogram, and I need to look at my equation sheet and see what is the equation for the area of a parallelogram. In that case, it's fairly straightforward. The area is the base times the height. Okay, well, if we look at this picture here, we see the base. See, we have a base of 6. Okay, so we've got that part done. And then with the height, we actually have this labeled for us. And notice here, the height is not the length of the slanted side here. The height is always going to be straight up and down, or that distance from the top to the bottom, or one base to the other. So if we want to find the height, we can look at this hint here. It says you must use the Pythagorean theorem to find the height of the parallelogram. So if I just isolate this and look at this from the side here, I have this triangle, I have h on the side, 3 inches on the bottom, and then we know that long side across from the right angle, the hypotenuse, is 5 inches. And we've used Pythagorean theorem before. You've used it in class, and then we've used it in these lessons as well. We know that's a squared plus b squared equals c squared. C squared being the hypotenuse, the side across from the 90-degree angle. So we look at this here. Let's say 3 inches is a, so we're going to have a squared, or 3 squared, plus b squared, which in this case is h. So plus h squared equals the hypotenuse squared, 5 squared. And then we need to simplify and get h by itself. So we have 3 squared, which we know is 9, plus h squared equals 5 squared, which is 25. Continue to solve. We have positive 9. We know we want to get rid of it. Subtract from both sides. When we do that, we're left with h squared equals 16. And then last step, I'll bring this up here. If I'm looking at this squared, remember I want to just get h. So to get rid of that, I'm going to square root both sides. When I do that, these cancel out, leave me with h. And then the square root of 16, or in other words, what number times itself is 16, that is going to be 4. Okay, so we have our height now. I'm looking at this, the area equals base times the height. So I just need to plug these in. So area equals base, which in this case is 6, and then times the height, which we just found to be 4. So final answer here, we see we're going to get 6 times 4, which is 24. So I'm going to write this in the box below. And we know, again, I need to make sure I get the unit correct. So I see we're dealing with inches over here. So it's 24 inches. And then since it's area, I want that to be inches squared. And that's going to be our final answer here. Okay, so I got 2 examples done. We'll keep moving. I'll try to speed this up a little bit to make sure we get through all the examples in easy time here. Okay, next one, as it's here, find the area of the kite. So this is where it might be more new information. You might not have found the area of a kite before. So what I'm going to do is I'm going to underline this here, and then I want to look at my formula sheet, and we see the area of a kite is, it says d1 times d2, and then divided by 2. And what that stands for is the length of one diagonal, or diagonal 1 times diagonal 2, and then all divided by 2. All right, with that in mind, it's fairly straightforward. We can see we're already given the lengths of the diagonals here. Given this long diagonal here is a length of 16 inches, and then we have a length of 9 inches for the other diagonal. So I can just plug these in here. Diagonal 1 can be 16, diagonal 2 can be 9, and then divide everything by 2. Now I just need to use order of operations to simplify. So 16 times 9, you can either do this in your calculator or in your head. So that's going to give you 144, and then divided by 2. And then 144 divided by 2, or cut in half, is going to be 72. So area here of this kite is going to equal 72. And then again, same thing as before as we're finishing these up. Look at the unit, so we have inches and then squared. That'll be my final answer here. Okay, and if I'm going too fast, or you need me to slow down on some of these, remember you can pause your video, but like I said, I want to go a little bit faster to make sure I can get through all these examples in time. Okay, so example 4, if we scroll down here, it says you need to replace the glass of your front windshield, but you need to know the area of it first. The shape of your windshield is roughly trapezoidal in shape. Find the area of the glass trapezoid needed to replace your windshield. So again, first thing is always going to underline the shape that we're dealing with the trapezoid. And then I want to write down that equation that I have for the area of a trapezoid. If I look at my sheet, area of that is going to equal the height times, it says b1 plus b2 divided by 2, or in other words, base 1 plus base 2 divided by 2. And really all you're doing in this case is you're taking the average of these bases here, the bases being the parallel sides in that trapezoid, because you're adding two things together and then dividing it by 2. So you find the average of those lengths, and then you multiply it by the height. So we have all that information. We don't need to find anything, so we're just going to plug that in. So that equals the height, which is 38, times base 1 plus base 2, so 72 plus 85, all divided by 2. And then again, I want to simplify here using order of operations. So first thing, I'm going to add 72 plus 85, which is going to give me 157. So I have 38 times 157 divided by 2. So I can do this in my calculator. 157 divided by 2 is 78.5 or 78.5. So I'll write this down here. 38 times 78.5. And if I multiply these in my calculator, I should get 2,983. So we have this here, area equals 2,983. Again, we're dealing with inches, and since it's area, still going to add the squared on the end. Make sure you get in the habit of doing that. Final answer, 2,983 inches squared. Okay, so that is all the ones with area, and just being able to use those equations. Now we're going to try to do the same thing with volume. The only difference being we might have a few more variables to deal with. Okay, so first one here, example 5, first one with volume I should say. If we're looking at the volume of a cube whose edges are 12 millimeters, I want to use the same process that we did before. I want to underline cube, and then if I look at that sheet, or I can actually scroll back up to the top here and look for the volume of a cube. Volume of a cube is going to be one of those sides and then cubed, and that's where we get the term, or taken to the third power in other words. So what I'm going to do, write this here, volume equals s and then to the third power. Good news, I only have one side length, so I just need to plug that in and then cube it. So I have the volume equals 12 cubed, or 12 to the third power, so 12 times 12 times 12. In any case, you can type this into your calculator. You can either do it to the third power or 12 times 12 times 12. Either way, you should get the same answer, which is going to be 1,728. So I'm going to write this in my volume box here. We are dealing with millimeters, and then this time when we're dealing with volume, instead of squared, kind of like we see with this shape, it's going to be cubed. Anytime you have volume, it is always going to be cubed. So that would be our final answer there. Okay, we'll try to knock these last two out here. Next one here, find the volume of the rectangular prism. So I have all these lengths. I have that shape. If I look at my formula sheet, I can see it says volume equals length times width times height. Okay, so this one's pretty straightforward. I just need to plug these in here. So I get volume equals length, which could be 11, times the width, which is 9, times the height, which is 3. So I just need to plug those all into my equation and then multiply them together. And when you multiply all these, you should get 297. So 297 and then inches cubed. Again, cubed because it is volume. Okay, and I'm going to try to get through this last one quickly. We have the volume of a triangular right prism whose base is a right triangle with base 3 and height 4. So I see if I look at my formula sheet here, volume is the capital B times the height, or in other words, the area of the base times the height. And it looks like I'm going to run out of time here, and I do want to spend some time explaining why this is the case. So I'm going to pause my video, and then I'm going to create another video for you guys to watch as well, or part 2 to kind of finish this up here. Okay, sorry about that. Let's get back to where we were here. Like I said, I do want to take some time and just make sure that we understand how to solve this last example because it probably is new information for a good amount of you, and want to be sure you understand why we're using these equations and what specifically we're doing to find the volume. So I'll erase this here. So first thing, like I said, is we look and we have a triangular right prism here. And I said the volume is this capital B times the height. So if we scroll back up to the top here, I want you to notice the difference between the area of a parallelogram, which is just base times height, lowercase b, and then the volume of a prism, which is base times height, except it's capital B, meaning the area of the base. So we're not just talking about one side length, like if I was looking at this side length, for instance, I'm looking for the area of one of the bases, or the top or the bottom of the prism. So in this case, I'd want to find the area of this whole triangle, and then we multiply by the height, because then I'm just asking, if I took this one triangle and kept stacking it on each other, how many times would I need to stack it on each other to get the volume of this entire prism? So in this case, I multiply it by the height. Okay, so that's why we use this equation here. So once I find the area of one of the bases, I can just multiply that by how many times I would stack it on itself. So for instance, if I just look, I see it says the base is a right triangle. So I'm going to draw this real quick. Let's try that again. Right triangle says width base 3 centimeters. In this case, when it says base, that's just meaning a side length, and then a height of 4 centimeters. Again, this is the height of this one shape, not the height of the entire prism. And then, like we see over here, it tells us the height of the prism is 12 centimeters. So first thing I want to do is I want to find just the area of this triangle here. Well, good news is we found that earlier. We know that equation, we have that. The area of a triangle is just the base times the height divided by 2. So lowercase b, and then the height of the triangle, not the height of the prism like we've said. So if I find this here, the area is going to equal the base, which in this case is 3, times the height of the triangle, which is 4, and then all divided by 2. So area equals 3 times 4, which is 12, divided by 2. So we see the area of the triangle is 6. And then again, we've said this before, we look at the unit, so it's centimeters. And in this case, since it's area that we're talking about, it's 6 centimeters and then squared. Okay, so we have this area of the triangle, or of the base of the entire prism. So again, if I'm thinking back to that picture of the prism, we've just found one of the triangles, and then we just need to start stacking it on itself. So that creates this. If you'll indulge me for a second, I'll try to draw a very bad description of what this prism would look like. Perfect. And that's basically the idea, is we've just found the bottom base, and then we slowly move it up. So volume equals the capital B, the area of the base, which we just found is 6, times the height, and we're not talking about the height of the triangle, but the height of the prism. So for instance, it would be this measurement right here if I was going up. If you can think of this as kind of a 3D shape, which I understand it's difficult too with the drawing. So the height of the prism, we already told, is 12. So we're doing the area of the base times 12 here. So 6 times 12. So volume equals 72. So we have our number here, so we're going to write this in, 72. Same thing as before, I want to make sure I have the correct unit and make sure I have the correct label at the very end. So we know we're dealing with centimeters here. With all of our problems with area, it's going to be squared, and then with all of our problems with volume, it's going to be cubed. So final volume here would be 72, and then centimeters cubed. Okay. So like I said, it's a different type of thinking than you might have seen before, different kind of problem than you might be used to in class. But if we understand what all the variables are, we just need to plug them in, and then it's just simple math from there. Okay, so that is all of the problems for this, or the example problems for this week. The rest of your time you can spend working on the practice problem. If you're in applied geometry, you have 4 problems to work on, and then if you are in geometry or geometry and construction, you have 8 problems to work on. So make sure you get those done, make sure you get those submitted wherever you need to, wherever your teacher is asking you, and then that is it. You should be good for all of these lessons that we've done for geometry. A couple other things I want to add before we close here. Number 1, there is an extension to this lesson as well, so you'll see at the bottom it says it all in the instructions, but basically extension for this is trying to find the surface area or the area of this museum. So this artist was hired to make an exhibit for a certain museum. So what the artist decided to do is take all the money that he was going to get from this or piece that he was commissioned to create and converted it into $1 bills, and then placed all those $1 bills around the museum, one right next to the other. So like I said, the instructions explain it all, but it's very interesting. You'll kind of try to find the surface area, and then you're trying to answer that question of how much did this artist get paid to do this art exhibit, and can I figure that out by finding the area on these walls and columns and things like that. So very interesting. Go ahead and check that out. And then last thing as well, do me a quick favor. If you guys have seen your geometry teacher in one of these videos, once you're done with this, shoot them a quick email and just let them know that or just shoot them a quick thank you email for the work that they've been putting into some of these lessons. All of your teachers have been putting in work depending on the classes that they teach. If you've seen your geometry teacher in one of these videos, that means they're on the geometry team, and every week we've been getting together and creating these lessons for you guys, and your teacher specifically had a hand in doing that. So make sure to thank them. I know it's a crazy time, but we made it through. So make sure you guys get this done, and then that's it. You can go enjoy your summer. I know I speak for all the teachers in our group when we say we miss you guys. We miss seeing you guys in class every day, but I'm excited to see you all back in the fall. So get this done, enjoy your summer, and we'll see you guys back hopefully in August. See y'all.